Okay, good day, students. We will continue our discussion about limits of transcendental functions. So today, we will focus only on logarithmic and trigonometric. So objectives, number one, compute the limits of logarithmic and trigonometric functions using tables of values and graphs of the functions. Then we will prove these limit expressions involving sine t over t and 1 minus cosine t over t. Okay? Using tables of values. We will start with logarithmic functions. So we will evaluate limits of logarithmic functions. Consider the natural logarithmic function. So by the way, we have two types of logarithmic functions. We have the common logarithmic and the natural logarithmic functions. So what is the difference between the two logarithmic functions? So natural logarithmic functions, you can see them as ln of x. Okay, so the common logarithmic is log x. So what is ln of x? Ln of x is basically, it is logarithm base e. When you have a base e, the Euler's number, it is considered as the natural logarithm. And the inverse of the natural exponential function y is equal to e raised to x. Okay, so ln of x is the inverse of the natural exponential function, our topic last time. So first, we will evaluate the limit of ln of x as x approaches 1. By direct substitution, you can use your calculator, but today we're going to use graphs. Okay, and table of values. So as x approaches 1 on the left side, so I gave some values of x, 0 0.1, 0 0.5, 0 0.9 to 0.99999. You will notice the value of 0.1 is negative 2.3. And all of the values of f of x, or the ln of x, as x approaches 1 on the left side, are all negative numbers. Okay? And it is approaching 0. The arbitrary L is 0. So let's investigate as x approaches 1 on the right side using table of values. So I started with 2, then 1.5, 1.1, 1.01, up to 1.00001. So f of x, or the ln of x, is 0.69, 31, 0.40, 54, 0.095, 0.00995, 0.0000995, and the last one is 0.0000995. So if you'll notice also, it is approaching 0. So the limit of the function ln of x as x approaches 1 on the right side is also 0. So therefore, limit of ln of x as x approaches 1 is 0. By direct substitution using your calculator, ln of 1 is also 0. We now consider the common logarithmic function. So we will proceed to common logarithmic function. So again, there are two types, the natural logarithm and the common logarithm. So the common logarithm, meaning you have your base is not Euler's number. Okay, so it's either you can have base 3, base 7, base 5. So for base 10, the decimal system, log 10 of x is the same as just log x. So if there is no base written in the common logarithm function, therefore you can consider that this is base 10. Okay? Now, let's evaluate the limit of log x as x approaches 1 using table of values. The values of x are 0.1, 0.5, 0.9, 0.99 up to 0.99999. Based on our table of values, 0.1 is negative 1, 0.5 is negative 0.301, zero point 0.9 is negative 0.045, 0.99 is 0.0043, 0.99 is negative 0.00043, and 0.999 is equal to negative 0.0004343. Okay, and the last one, 0.9999 is equal to negative 0.00000043. So if you will notice, as x approaches 1 on the left side, it is approaching closer and closer to 0. And approaching from the right, as x approaches 1 on the right side, so I give the value for x as 2, 1.5, 1.1, 1.01, 1.0001, 1.0001, and 1.00001. The corresponding value for those values of x to log x is 0.3, 0.17, 0.04, 0.004, 0.00004, 0.000004, and 0.000004. So approaching from the right also, it is equal to 0. So the arbitrary value of L is 0. Approaching from the left and approaching from the right. And if you will use direct substitution, log x or log 1 is equal to 0 using your calculator. Okay? So aside from using your calculator, table of values, we will use graph. The red one, look at the illustration, the graph. So the red function is ln of x, and the green function is the log x or log 10. Okay, so logarithm base 10 of x. Let's answer limit functions. What is letter A? What is limit of ln of x as x approaches e? So kindly pause the video and try to answer. Okay. So as x approaches e, what is the value of the Euler's number? 2.7 something, right? On your graph, on our graph, 2.7 something is already marked. And the corresponding value of f of x of 2.7 something is 1, because that is approaching from the left and approaching from the right. It converges to 1 because, again, logarithm is the inverse of exponential function. The natural exponential function, or the e raised to x, is equal to, the value of e raised to 1 is 2.7 something. Okay, so that is the value of the Euler's number. Okay, so if you're going to inverse it, so the limit of ln of x as x approaches the Euler's number, so that is equal to 1. How about letter B? So what is the limit of log x as x approaches 10? We know that the base of log x, if the base is not written, by default, it is base 10. So therefore, the limit of log x as x approaches 10 is also 1. So let's look at the graph. As x approaches 10, it is on the, so x is equal to 10, and log x, f of x is equal to 1. Let's have letter C. What is the limit of ln of x as x approaches 3? So your x is 3. So the red function is the ln of x. More or less, the value of f of x is 1 point something, right? So let's see. So 1.09. So if you will use your calculator, ln of 3 is 1.09. Let's have letter D. What is the limit of logarithm log x as x approaches 3? So the green function on your graph is your logarithm. As x approaches 3, your f of x is just approximately 0.5, right? So let's see. So log 3 is 0.47. Direct substitution using your calculator is 0.47 something. So let's have letter E. The limit of ln of x as x approaches 0 coming from the right side. So coming from the right side, and it is approaching 0. So looks like the logarithmic graph or the logarithmic function has an asymptote of 0, right? So approaching from the right, it is going to the negative f of x. So therefore, the answer here is negative infinity. How about letter F? The limit of log x as x approaches 0 from the right side, the green function, it is also going, okay, so it is approaching negative infinity. Okay, so any questions? So again, you will answer the Google Forms exit pass. So if you have any questions, clarifications about our lesson or discussion for today, you can put your questions and learnings on your evaluation. Now we will proceed to trigonometric functions. So what are the limits? So what will be the limits of the function trigonometric functions? So let's have the first example. Evaluate the limit of sine x as x approaches 0. So using direct substitution, so what is sine 0? Okay, so we will use table of values in determining the limit of the function. So using table of values, I have 0 approaching from the left side, negative 1, negative 0.5, negative 0.1, negative 0.01, up to negative 0.00001. The corresponding value of f of x, or the value of sine x, is negative 0.8, negative 0.47, negative 0.09, negative 0.009, negative 0.0009. Okay, so if you notice again, coming from the left side, as x approaches 0, the function sine x also approaches 0 on the left side. How about on the right side? My x values are 1, 0, 0.5, 0.1, 0.01, 0.001, 0.0001, and 0.00001. So the corresponding value of sine x with these values of x are 0.84, 0.47, 0.09, 0.009, 0.0009, 0.0009, 0.00009. So also approaching from the right side of 0, the arbitrary L is also 0. So therefore, the limit of sine x as x approaches 0 is 0. Using direct substitution, sine 0 is 0. So let's have other trigonometric functions. Okay, so consider the graph of the function is equal to sine x. Find the limit of the following functions. Letter A. What is the limit of sine x as x approaches pi over 2? Inspect the graph, or just let's find pi over 2. So pi over 2, then what is the corresponding value according to the graph? So it is positive 1, right? Approaching from the left and approaching from the right, it is 1 using the graph. Letter B. What is the limit of sine x as x approaches pi? Approaching from the left and approaching from the right, according to the graph, it is 0. Letter C. What is the limit of sine x as x approaches negative pi over 2? So approaching from the left and approaching from the right, based on the graph, sine x, the limit of sine x as x approaches negative pi over 2 is negative 1. And the last one, letter D. What is the limit of sine x as x approaches negative pi? Okay, so approaching from the left and approaching from the right, it is 0. Questions, clarifications? Okay, so we will proceed to our next example. Evaluate the function sine x over x. So this is one of our objectives. We must get, or we must evaluate the limit of this function sine x over x. Okay, so direct substitution, if we will go into the substitute sine 0 over 0, if we will substitute 0 to sine x over x, it will become sine 0 over 0. And we know sine 0 is 0 and x also is 0. So therefore 0 over 0, it will become indeterminate. How do we evaluate? Okay, so like last time, using in our discussion in exponential functions, we will use table of values. So there is a shortcut in evaluating this sine x over x, but it involves derivatives. Okay, so we will discuss that about derivatives. So for now, we will use table of values. So I prepared table of values approaching from the left side and approaching from the right side. So you know the drill. So we will substitute the table of values. My value of x approaching from the left side, and it equaled this 0.99, 0.999. If you'll notice, they are almost identical. They are approaching 1, okay, from the left side. And on the right side, also it is approaching 1. And by comparison, by inspection, you can see they are similar. So later, we will see the graph and you will see why they are similar. So approaching from the left, it is 1, and also approaching from the right of 0, it is also 1. So therefore, the limit of sine x over x as x approaches 0 is 1. Okay, so let's inspect the graph. Yeah, so it looks like a downwards parabola. So f of x is the same. Even though it is approaching from the left, you have negative values, and approaching from the right, you have positive values, but f of x are the same. Next example, 1 minus cosine x over x, that is our function. So what is the limit of that function as x approaches 0? Okay, so direct substitution, 1 minus cosine 0 over 0. Cosine 0 is 1, so 1 minus 1 is 0 over 0. So it will give you indeterminate form. So we cannot have a indeterminate answer. So we will find another way in evaluating the function using table of values. Again, we have a shortcut, but it involves derivatives. So for now, we will use table of values. So the same values I prepared, approaching from the left and approaching from the right. So let's see the equivalent value. So if you will see, negative zero point 0, negative 0.04, negative 0.004, negative 0.00004, and negative 0.00004. So approaching from the left, it is going, or it is approaching 0. And approaching from the right, so instead of negative, it becomes positive. So we will see later the graph. So what does the graph look like? Identical, but instead of negative, it becomes positive. So approaching from the left of the function, it is 0, and approaching from the right also, it is 0. So therefore, the limit of the function 1 minus cosine x over x as x approaches 0 is 0. So whenever you encounter this function 1 minus cosine x over x, or 1 minus cosine t over t, or 1 minus cosine a over a, so any variable, it is the same. Okay, so the answer is 0. Okay, so let's inspect the graph. So as x approaches from the left side, so you have negative numbers or negative values. Okay, and inverse relationship, okay, from the left side and the right side. Again, if you have any questions, so you can put your questions in our exit pass by answering our Google Forms evaluation. Okay, so that's all for today. Answer your quiz that I will send in our group chat. Goodbye, God bless.